I decided I wanted to do a little bit better measurement of the polymer capacitor versus the multi-layer ceramic capacitor. So I've mounted them on a printed circuit board. This is the multi-layer ceramic capacitor over here, and this is the polymer capacitor. And I've soldered some leads as close as I can to the pins so that I can get right on the pins and get a better measurement of ESR, for example. But the first test is going to be with the B&K Precision battery tester, which is this guy here, and he can measure the capacitance and the ESR. So if I connect up, say, the multi-layer ceramic capacitor to these fancy leads, you can see that it's saying 8.8 microfarads and 0.14 ohms. And we can hook up the scope at the same time. To show that it's using a 1 kilohertz signal to measure the capacitance. And it's also calculating the dissipation factor. Let's see if I can find that. So here we have the capacitance and the dissipation factor. So it's 8.8 microfarads. Dissipation factor is 0.008, which corresponds to an ESR of about 0.13. And when we were measuring the RC, it computed 0.14. So the dissipation factor to ESR relationship is, I guess, ESR is equal to the dissipation factor time, or divided by 2 pi fc, where f is the frequency and c is the capacitance. In this case it's 10 microfarads and the frequency is 1 kilohertz. So it all more or less works out, but I wouldn't put too much credence in too many significant digits. So 0.13, 0.14 ESR from this computation, and we're going to compare that to the ESR calculated by this peak meter. But let's first have a look at the polymer cap. So here we go. And the polymer cap is 0.3 ohms, which ESR, which is almost double the multi-layer ceramic cap. One of the reasons for this is that these are 50 volt capacitors, and the polymer caps that are lower voltage would have a lower ESR. But since in my experiment I wanted a higher voltage, I have to live with the higher ESR. And let's just go over to the dissipation factor to show that it is indeed higher. So the other capacitor, the multi-layer ceramic, was 0.008, and here we have 0.019, which is a little bit higher, almost double. And now let's try it with this peak meter and see what we get there. So the peak meter on the multi-layer ceramic make sure these leads aren't touching each other. So this is saying that the capacitance is 9.22 microfarads and the ESR is 0.02 ohms, which is significantly lower than what the B&K measurement was. So this one is using a different method of calculating. I don't know if we can see that on the... Let's get it in the light. But it has these nice gold clip leads, which will give us a low impedance connection to the capacitor. And let's try the polymer cap. And this one is 0.04, which is double the ESR of the multilayer ceramic, which is pretty similar to what we got before in terms of the ratio. Saying this one's 9.53 microfarads. So although we're not exactly sure about the accuracy, they seem to be measuring the same ratio as a difference in ESR between the two capacitors. And of course, even the reading of the capacitance is slightly different, so we're going to measure using these other meters as well. They only measure capacitance, they don't measure ESR. I guess we'll figure out that these meters all have slightly different capacitance measurements, and we can't really take the very many digits of precision as the gospel.